Hi students, Department of Technical Education, Telangana. My name is T. Rajshekar, working as a lecturer in Civil Engineering, SRRS GPT Silsila. So this subject is for the third semester Diploma in Civil Engineering students of second year. So the subject name is Engineering Mechanics. Subject code CE302. So today we are going to know the topic on from the chapter Forces and Movements. Let us see about the forces and movements introduction. So let us see the objectives. So in this class what you are going to learn, that is, on completion of this period you would be able to know, define the term engineering mechanics. So this subject is very important in the civil engineering stream, because if you know the engineering mechanics, you can know the related regarding the forces and movements in the civil engineering field. So this subject is coincidentally connected with the another subject, that is strength of materials and theory of structures. Okay, so engineering mechanics are the basics fundamentals you are going to know in this subject. Okay, so this engineering mechanics is connected with various branches in engineering mechanics. Okay, and there are the terms, that is explain the term physical quantities. Okay, moreover you will going to see the distinguish between scalar and vector quantities. So these are you will learn in the first year of physics. So meanwhile some of the forces and movements were also there in the engineering mechanics, but here you will know defining the regarding the force, what is the force. Okay, and define the terms deformation and rigid body. Okay, so you will be going to the deformation and rigid body. And so let us see the our mechanics and engineering mechanics. So what is engineering mechanics? Okay, so here the word you can see, that is mechanics. Let us see the first mechanics. So it is the branch of science which deals with the action or effect of forces on bodies. Okay, so it is the science, because this mechanics word, it is related with the certain engineering branches. Okay, so in the word itself you can observe the mechanical action. That means all the when the force is applied on anything, it is known as the mechanic. Okay, for example you can see the vehicle or any other engines. So whatever the vehicle or engine should run, we should apply the force, or they should need the some of the liquids and oils. Okay, so whenever applying it, it will be running. So that here in the branch of science also we will be applying the some of the action or effects. Okay, that is known as forces on bodies. Okay, so here the bodies means whatever the loads or stretches we are applying, and the forces is known as the bodies. Okay, so let us see the engineering mechanics definition. So it is very important in the your examinations also. So let us see engineering mechanics is, it is the application of principles of mechanics to engineering problems. So where the problems will be generally rectified in this engineering mechanics. Okay, so this will be useful for the application of principles of mechanics to engineering problems. Okay, so remember, so the engineering mechanics, totally the definition is, it is the a branch of science which deals with action or effects of force on bodies with application of principles of mechanics to engineering problems. Okay, so let us see here the engineering mechanics, the world which is divided into the various streams. That is, this engineering mechanics is divided into the statics and dynamics. Okay, it is divided into the statics and dynamics, and from dynamics it is divided into the kinetics and kinematics. Okay, so you have seen the on related the statics and dynamics and kinetics and kinematics in different chapters. Okay, so remember this flow chart, it is very important. So engineering mechanics is also further divided into the four streams. So let us see here what is statics. Okay, so this is very important. What is the statics? So statics, dynamics and kinetics and kinematics. So these four definitions are very important in your uh, throughout life. Okay, so what is statics? So let us see. It is deals with forces on bodies at rest. Okay, what is statics here? It deals with forces on bodies at rest. That means you say, suppose a bar is there. Okay, iron bar, anything, so it is standard. Okay, so it is at rest, suppose it is in the stopped position. Okay, if you apply the force here, okay, so whatever the force, suppose it is called P. Okay, this is say P. So when you are applying the force when it is in the rest position, it is called statics. Okay, so whatever the forces, whether it is the horizontal force or vertical force or downward force, okay, or any other inclined force, okay, whichever the forces you are applying on the bodies at rest, it is known as the statics. Okay, remember. And next is dynamics. So dynamics is deals with forces on bodies in motion. Okay, so the bodies in motion means you can see when it is in the running position. Okay, running position or in the moving position. Suppose you can see any other stretchers or any other related uh, auxiliary movements which are there. So you can see the bar which is in the a beam or anything. Okay, so this is a beam, a singular reinforcer beam, or so I will going to say regarding what are these beams are also. You see in a stretcher, if you are applying when this in the a rest position or in the motion condition. Okay, so it also deals with the horizontal forces and vertical forces. Okay, so which it is in moving condition. Okay, so it deals here which will be in the sides, horizontal and left side or horizontal right side forces. So it is related with the motion. Okay, and next is kinetics. So kinetics is part of dynamics that deals with the study of motion of bodies and the forces acting on them. So here this part of dynamics that is deals with the study of, it is motion of bodies. That means where the bodies are in motion. Okay, when the forces are acting on them, it is known as kinetics. Okay, remember. And next is kinematics. So kinematics is part of dynamics that deals with the study of motion in abstract without reference to the cause of motion. So that means here this part of dynamics also, it is deals with the study of motion. Okay, so when the motion is in the condition of the loads or bodies, so without reference they will cause the motion, that is known as the kinematics. So nothing but it, the both kinetics and kinematics are deals with the dynamics, bodies in motion. Okay, so this will be the meanwhile in the condition. So next, what is physical quantity? So you remember the definitions which are there, these are very important. Statics, dynamics, kinetics and kinematics. Okay, so let us see the physical quantity. So physical quantity, it is determined, is the result of measurement and is usually expressed as a combination of a numerical value and a physical unit. So here the physical quantity is determined, that is nothing but it is the result of measurement. Okay, so whatever the quantity of result is there, so that is usually expressed in a combination of numerical values and physical units. So the units which are we are expressing for the measurements, okay, so for the loads or anything, that is known as the physical quantity. Okay, so for example he has given that is p means load. P is equal to 42.3 into 10 to the power of 3. So it is also called 10 cube. Okay. So if it is written 10 on top of 2, it is 10 square. Okay. That means 10 into 10. So it is written 10 into 3. That means you can write 1000 also. Okay. So how much 10 into 3? It becomes 1000. So that means nothing but 10 cube is equal to 42.3 kilowatts. Okay, it is determined as 42.3 kilowatts. So with here P representing the physical quantity for power. You remember here what is P here? So generally P representing the physical quantity for power. So whether as in our mechanics condition we will say the load also. Okay, so whether here 42.3 into 10 cube being the numerical value split into 42.3 and K, the SI, it is prefix representing the 10 cube. So the SI which is there, that is a prefix representing the 10 cube. So it is a symbol unit of power. Okay, so W being the symbol for the unit of power, the watt. So this is a physical quantity example. So next let us see the physical quantities and classifications. So there are physical quantities are divided into scalar quantities and vector quantities. So this is the another important topic in the engineering mechanics. So scalar quantities and vector quantities are divided from the physical quantities. So let us see the what are scalar quantities. So these scalar quantities are quantities which have only magnitude but no direction. So observe here. So that means they doesn't have the direction but they have only the magnitude. So those are scalar quantities. Example, a distance. So example was given, that is a distance. Okay, you remember the scalar quantities are quantities which have only magnitude but no direction. Example, distance. So the distance will have only the magnitude but they does not have the direction. You can see, suppose an example is given, the distance is 10 meters. Okay, so how can we measure here? It doesn't have the any which have only the magnitude but no direction. Okay, it goes in the any type. Some more examples for scalar quantities are speed. So can you define the speed in which area it goes? And mass and area, volume, time, energy and density. So these are the examples of scalar quantities. Okay, remember scalar quantities which have only magnitude but no direction. Example is distance. Okay, some more examples for scalar quantities are speed, mass, area, volume, time, energy and density. So this is very important, you remember. And the next is vector quantities. So the difference between scalar and vector quantities is very important. So this should be kept in the mind. So vector quantities are quantities which possesses magnitude as well as direction. Okay, so comparing with the scalar and vector quantities, here you can observe that in vector quantities it has which possesses magnitudes as well as direction, but whereas in scalar quantities only magnitude has but which has no direction. So here example it is given displacement. So the displacement you can see here a to b which is there, suppose a 4 meters by 4 meters by 2 meters was given. So here the displacement from A to B has both magnitude and direction. So that means it is a bar which is given. So the three sides it has the shape and loads. So whereas the A and B can also be have magnitude and direction. So that is we are determining A and B. This is called the displacement also. So meanwhile it shows the proper magnitude and direction and shape of the vector quantities. So magnitude here is equal to 2 meters and direction is vertically downwards. So that is this is 2 meters the magnitude and the direction is vertically downwards. So that's why we will say it is the vector quantities. So other examples are also given. Those are velocity, acceleration, force. Okay. So velocity is also determined as meters per second, acceleration due to gravity, and force by load by area. Okay. So these are the vector quantities. So now very important definition in the engineering mechanics is force. So force is also called load. Okay, so this is very important. Force is that which changes or tends to change. Remember this definition. Force is that which changes or tends to change. That means a load which appears on a body, okay, which whatever the body the load or force is applied, so it can be changes or it can be increases. Tends means it can be increases to change the shape of the body also. So that is known as force. So here the state of rest of a body, we can write the another definition. The state of rest of a body or the uniform motion of the body in a straight line. That is, force is that which changes or tends to change the change state of rest of a body or the uniform motion of the body in a straight line. So you can see example was given. Suppose it is a body is there, the pink color which is determined, this is a force. Here force was applied. Okay, so when the force you applied here, it moves. The dotted lines which are there, it is moving from one place to another place. So it is nothing but the uniform motion of the body which is in straight line. Okay, so this is when we apply the force. If we apply the force only, it moves in a certain direction. That is the uniform motion. And if the state of rest of a body which is there, okay, so you apply from the topwards, so it will be applying the load on the body itself. So it is the state of rest of a body, but it doesn't move. Okay, so when the load applies on the body, it changes its appearance or the diameter or length of the body. Okay, so that is known as the force. That's why we are saying telling here it changes or tends to change. So here the force is also a vector quantity. It is not scalar quantity, it is vector quantity. So remember, the force is very important quantity. So what are the units for force here? the unit of force in SI system is newtons. It is determined as N. So the force is determined by the N. Remember, the unit of force in SI system is newtons. So once again you remember, force is that which changes or tends to change the state of rest of a body or the uniform motion of the body in a straight line. So the force is a vector quantity. The force of units is SI system is newtons. So next, force and system of forces. Example, what are the system of forces are there? A gravity force, force of magnetic attraction, and tractive effect of a locomotive. So let us see here. Mathematically, force is equal to mass into acceleration. So here, this is the force is the acceleration. So generally, so mass into acceleration. So here that is mass is equal to 1 kg, acceleration is 1 meter per second square in SI units. So that is equal to 1 Newton. Okay. So the force is equal to mass into acceleration. Mass is equal to 1 kg and acceleration is 1 meter per second square. So it is determined as 1 Newton. So you can write it in the 1 kg meter per second square also. Okay, 1 kg meter per second square. So next is system of forces. Let us see system of forces. So here the two or more forces acting simultaneously on a body constitute a system. The two or more forces acting simultaneously on a body constitute a system is known as system of forces. So these system of forces are, they are two or more forces acting simultaneously on a body constitute forces. Suppose you see an example. This is a body. So a body is there, a structure of a body. So here, if we apply the here one force, a horizontal force, and you apply the a vertical force, and you apply the any other inclined force. Okay. So the forces which are applying on a body, so generally horizontal, vertical, or inclined. Okay. So the downward forces. So these are called system of forces. So but they should act simultaneously. That means at a time these forces should act on a body. Those we will call system of forces. So generally on a body, which are the forces, you can see example just like dead loads, wind loads, live loads, snow loads. On a structure or any building, you can see so many loads will be acting daily. So those are determined as system of forces. So next is deformation and rigid body. So what is the deformation and rigid body? So there are two equal and opposite forces acting along the same line nullify each other. So that means here the two equal and opposite forces which are acting along the same line nullify each other. So this is deformation and rigid body. So that means here on a body the two equal and opposite forces, that means this is a one force and this is another force. So here these two forces are acting on the body equally and opposite forces. Okay, so they will be meet at each other. That is the deformation of forces. So this will be tends to changes at the center of the point of the body. As a result, the body remains in the same position. Okay, so here this body will be not moving in any condition because the loads are applied in both directions. So the forces produce a change in the shape of the body, size of the body, which is called deformation. So here, when the two forces are among acted oppositely, so what it happened, it does not changes its position, but the shape of the body will be changed with these dotted lines, bulge, or it will be extended in any direction, which is called deformation. So this is a very important definition. Okay, so here the two equal and opposite forces which acting along the same line, they meet each other. So this is a deformation and rigid body. A body not undergoing appreciable deformation under the action of forces is called a rigid body. So that means here a body which is not undergoing an appreciable deformation under the action of forces is called a rigid body. So let us see the new topic, that is characteristics of force. So we have seen up to now what is the force. So the characteristic of a force are magnitude, direction, sense, point of application. So in characteristics of force, we can see the magnitude, what is the direction, and what is the sense, and what are the point of application. So what is the magnitude of a force? Let us see the what is the magnitude of a force. So here it gives us the quantity of force. This magnitude gives us the quantity of a force. That means how much force we are applying on the body, it shows the quantity. So that's why we will determine as magnitude of a force. For example, 100 newtons. Okay, so how much load we are applied? This is 100 newtons. The load we are applying on the, so this gives the our load. Okay, so generally this is the base appearance for the magnitude of the force. So it shows the whatever the load, how much it is applying from small loads to heavy loads. So this determined as 100 newtons. So then next, what is the direction of a force? It gives us the line along which it acts. So this direction of force, it shows the direction in which the force is acting. Okay, so the direction can be represented in the following ways. That is, by indicating the angle that the line of action of the force makes with the reference axis, x-axis and y-axis. Okay, So this direction of force, it gives the line along which it acts. So this direction can be represented in the following ways, that is in the by indicating the angle that the line of action of the force makes with the reference axis, that is x-axis and y-axis. So you can see this is the our direction. So these horizontal forces will represent x-axis, the vertical forces which represents y-axis. So from this we can indicate the an angle which we there the loads. Okay, so just like x axis, it is determined the angle is 45 degrees. And next, direction of a force. Let us see the direction of a force here. So by indicating the angle that the line of action of the force makes with the geographical axis. It means this direction of a force which is there, by indicating the angle that the line of action of the force makes with the geographical axis. So the north, south, east, west directions, they will be indicating the angle, the line of action of force when it makes a geographical axis. This is the example. And the next is the sense of a force. What is the sense of a force? It represents the way in which the force acts along the line of action. So this is shown by placing an arrowhead on the line of action of the force. That means it represents the way in which the force acts along the line of action. So this is shown by placing an arrow head on the line of action, the force. So this is known as the sense of a force. So here you can see the force which is there from the north and south and from east and west direction. So from this, the force which goes in the line of action, okay, so that is determined with the F. So this is placing an arrowhead on the line of action of the force. So and which that determines the a vertical load determines the F to the direction or line of action. It is also determined as sense of a force. That means towards the line of action or away from the line of action. So this is known as sense of a force. And the next is point of application of a force. So what is the point of application of a force? It is the point at which the force is applied. So that means here it is the point at which the force is applied. Let us see the example here. A body is given A. So it is the line which is represents the center of the body. Okay, so this is the line which represents the center line of the body. So this is a body is given, and here the 100 newtons load which is passes here. So at the point which is there, it is A. So here A is the point of application of the force which represents 100 newtons. That means in which direction where the point of application of force is shown, it is known as point of application of a force. Here also you can see the another example. Point of application A, the line of action, it is direction 40 degrees to horizontal. We will say it is 100 newtons of load, it is 40 degrees to horizontal. Why is here horizontal? So this is the horizontal. This is the horizontal. So sense is pull. What is taking here? So this body, it is pulling to the 100 newtons direction. So this is called sense. Whatever the load is pulling the body 100 newtons, it is called sense. The point of application is A. And what is magnitude? The load which is acting, how much load it is shown, that is known as magnitude. So remember, the point of application is A, the line of action is 40 degrees to horizontal, and the sense is pull, magnitude is 100 newtons. The next, now let us see the system of forces. When several forces of various magnitudes and directions act upon a body, they are said to constitute a system of forces. So this is system of forces. So here the several forces, that is the system of forces, are determined here now. So the force systems, it is divided into the coplanar and non-coplanar. So again from coplanar forces, it is determined as collinear and concurrent. From here again non-concurrent. And from here non-coplanar forces, it is determined as parallel and non-parallel forces. So from non-concurrent forces, it is determined as parallel, non-parallel. And from parallel, it is determined the forces are like parallel and unlike parallel. So this is very important format. These are all the system of forces. So depending upon their conditions and magnitudes and directions, whatever they act upon a body, these are all said to be system of forces. So from force systems, it is divided into the coplanar and non-coplanar forces, and again from coplanar it is divided into the collinear, concurrent and non-concurrent, and from non-coplanar it is divided into the parallel, non-parallel, and from non-concurrent it is divided into the parallel and non-parallel, and from again from parallel it is divided into the like parallel and unlike parallel. So let us see the one by one. So before going into these coplanar forces, so once you observe this system of forces very clearly. So this in the force of systems, the coplanar forces and non-coplanar forces means, so some forces will be acted upon a body applying the force, but some forces which does not apply the load but they move or act upon directly the force. That means those are the some of the differences between the coplanar and non-coplanar forces. So that means some forces will be just like parallel and some forces will be unlike parallel. The meanwhile The forces which are acting on the body, they show the proper in the direction, but some forces cannot show the direction and magnitudes of the forces. So that's why it is divided into the system of forces. Okay, so before going to the system of forces, let us stop here. So in the next class we will going to see the system of forces. Okay, so thank you, have a nice day.